Hello and welcome to the Chapter 5 podcast in Section 5.4. Today we'll be discussing enthalpies of reaction. Enthalpies of reaction are basically enthalpy changes that accompany a chemical reaction. The change in enthalpy will be the final enthalpy minus the initial enthalpy, the difference, or we can do this in terms of products minus reactants. Thermochemical equations are basically chemical equations that include the enthalpy change that's associated with it. So in this figure below here we have a reaction between hydrogen and oxygen. So this is a balloon filled with hydrogen, and then we provide some activation energy to combust the hydrogen inside, and this is associated with the number of joules leaving the system, which I guess would be the balloon in this case, and we get a water vapor as a result. Some things to be aware of with respect to thermochemical equations and enthalpy diagrams. Enthalpy is an extensive property, and what that means is that it depends upon the amount of matter present. So this change in enthalpy is a stoichiometric quantity. So you can make a ratio between 1 mole of methane and this many joules of heat associated with it, or 2 moles of oxygen with this many kilojoules of heat associated with this reaction, and so on. We can reverse enthalpy changes. So if we can take a reaction, we can reverse the arrow. So if you compare this reaction here to the reaction in number 1, it's the same reaction. All we did was just turn the arrow over. But when we turn the arrow over, notice how the magnitude of the delta H now is equal but opposite. So the sign changes. So what was exothermic in one direction is endothermic in the opposite direction. Also, enthalpy changes here are specific for the state of matter here. So here, the state of matter makes a difference. So notice how when we change the state of matter of the water, so we go from liquid to gas, the enthalpy change is not the same because of that. So it is state dependent. Here's an example of one way to do an enthalpy calculation. So here again we can make a stoichiometric ratio. So here we have our breakdown or decomposition of hydrogen peroxide, and these are the products produced, and this is the enthalpy change associated with it. If we want to know how much energy, so this reaction, so for every 2 moles of this is how many kilojoules of energy we would expect to leave the system or be released. Let's say we want to know how much delta H or Q would be if we had 5 grams of this. Well, again, we can use, this is basically like a stoichiometry problem, where this is a mole ratio, right? Moles of hydrogen peroxide to kilojoules. So we need to convert our 5 grams into moles. We multiply our 1 mole we multiply our 5 grams by 1 mole over the molar mass, and then this comes from our balanced chemical equation. So it's just like stoichiometry. Instead of having moles of something from the reaction, we just have the enthalpy instead. And notice if you cancel out all the units, you end up with kilojoules of heat. So 14.4 kilojoules is the amount of heat we would expect to be released if 5 grams of hydrogen peroxide decomposes. And we'll do some more problems in class, because this is one kind, and there'll be some other ones as well. So until next time.